Hi everyone, I'm Noreen Noor. Today I'm sharing my survey paper presentation with you. And the topic of my survey paper is testing and validation of machine learning in aviation safety systems. Basically, we are seeing AI used everywhere in aviation, from predicting maintenance issue to helping with accident analysis and flight safety decisions. But since these models learn from data, we need to make sure they are safe, explainable, and reliable before using them in real world operations. In this presentation, I will quick walk you through why this topic matters, what kind of research I looked at, the methods and testing frameworks involved, and finally what I found and what still needs to be improved. So let's move towards next slide. Introduction. Before we get into testing, this is like the quick overview of how aviation systems are changing. If you can see there are two flow charts. First one is traditional one, which is like rule based, and the second one is machine learning based. Traditionally, aviation safety relied on rule-based system. You had a set of fixed rules that software followed to make decisions. But now, with machine learning, systems learn directly from data instead of just following predefined rules. This shift is actually powerful because machine learning can detect patterns that humans or traditional system might miss, like small sensor changes before a failure. But it also brings new risk. Since these models learn from data, they can behave unpredictably in new situations. That's why testing and validations are so important in this field. And the reason is like to make sure these models stay reliable, robust, and safe in high risk aviation environment. So this is what is included in an introduction. After that, we have motivation. Why I am doing this research topic, like having this research topic in survey paper. The main reason this topic matter is because aviation accidents often happen due to system failure or human errors. Machine learning has the potential to actually prevent many of these unsafe situations by detecting problems earlier. For example, predicting when a sensor might fail or when flight conditions are becoming risky. But this only works if the machine learning models themselves are tested properly. If the testing is weak or incomplete, the system might make the wrong prediction at a critical time. And in aviation, that could mean serious or even catastrophic consequences. So, motivation here is really about safety, making sure that we use AI or machine learning in aviation, we can trust the results completely. It also consider the lives of all the people here. So next we have research objectives. After understanding why machine learning testing in aviation is important, here are some main goals of my survey. The first one, I wanted to identify how machine learning models are actually being tested in aviation, what approaches are used, and what's missing. Next, if you can see, I looked at how effective those testing frameworks really are. Do they catch faults? Do they make systems safer? These are the questions I think about that. Then I compared aviation with other safety critical industries like healthcare, automotive to see what we can learn from them. And finally, I aim to highlight gaps in the research and suggest ways testing and validation can be improved in aviation system. So these are the research objectives for now. After that, I collected some questions after reading all the papers from Google Scholar or the papers which other publish. So this part basically guided how I approached the survey. The first question, research question number one, look at what testing and methods already exist for aviation machine learning system. Because a lot of work has been done in general AI, but not necessarily customized for aviation. And then question number two, ask how effective those methods actually are. Do they work well in real environment or are they mostly theoretical? And the third one digs into why traditional testing doesn't work well for machine learning. Unlike rule-based systems, machine learning can change behavior based on data, which makes it unpredictable. And if we can see, Question 4 through 7, it actually focuses on the frameworks and matrices used to measure machine learning reliability, things like deep explore, deep test, deep gauge, that evaluates robustness and coverage. And finally, research question number 8 to 10 ask how we can build trust in machine learning system through explainability and automation. Because in aviation, understanding why the model made a decision is just as important as the decision itself. So these are the research questions we have right now. After that, we have fall detection in aviation. In aviation, machine learning plays a key role in fall detection and early warning systems. It helps identify small sensor anomalies that might not be noticeable through traditional methods. So, a traditional rule-based system can mix complex nonlinear relationship in flight data, things like temperature, pressure variations that combine in unexpected ways. Machine-based learning systems, on the other hand, can detect these hidden patterns in real life, which are not done by traditional systems. So it allows for faster responses before an issue created or accelerates. So this makes machine learning especially powerful for preventive maintenance and operating safety in aviation. That's why it has like more importance as compared to the traditional one. And now we have studies in fault detection. I have one slide in which I just mentioned about these three papers, and the next one contains like a whole table about this. So now let's take a look at some key studies in fault detection that use machine learning. The first one uh, by Ahmed in 2014 used a random forest algorithm to detect aircraft system faults. It performed better than traditional one because it could learn complex patterns from sensor data. Then we have another one which is published in 2020. Uh, took it. It is actually like a step further with the physical informed machine learning models. They combine physical flight systems or dynamics with machine learning, which made their model more reliable and reduce false positives. So this is what they did in 2022 paper. After that, we have another one which is like published in 2025, the latest one. It used deep learning on NTSB accident reports. NTSB, which has like all the real data sets about what accidents are already happen and all the information related to all the features over there. So they train sequential model to identify unsafe states based on past accident data, which really shows how text-based safety reports can be turned into predictive insights. So that is really helpful. And this table actually shows us all the information about those techniques, the data set they use in the papers, and these are all related to the fault detections and what kind of algorithms are used, and the key findings are on the right side. Next, we have AI safety studies. So moving on to AI safety studies, this table actually highlights key research that focuses on how artificial intelligence can be tested and validated safely, especially in high risk domains like aviation. The first paper, Concrete Problem in AI Safety, it identifies core issues such as robustness and safe exploration. It sets the foundation for how we should approach testing in machine learning systems. And the second paper, if you can see from Nobel Prize, it got Nobel Prize for Safety Risk Management. So it looks, if you look at this, it has like in 2018, it has Uber autonomous vehicle crash. It connects human decision making and accountability to AI behavior, showing how human factor needs to be a part of AI testing. If you can see the third paper, AI for safety critical system in industrial and transportation domains, it proposes a taxonomy, basically a structured framework to organize how safety validations can be done. It's one of the most adaptable for aviation, if we can talk about the aviation systems here. And finally, the fourth one is artificial intelligence and safety critical system. That is a systematic review identify the biggest gap, but a kind of gap like a lack of unified testing standards across industries. So this directly connects to aviation, where consistent validation frameworks are still missing. So overall, these studies emphasizes that Safe AI isn't just about good algorithms. It's about making them explainable, testable, and reliable under every condition. So that's what is discussed in this table. After that, we have machine learning testing frameworks. So now moving on to machine learning testing frameworks, we have like basically these are the tools which I mentioned in these three blocks. It helps ensure machine learning models, which we are using from before, like papers, are they behaving safely or reliably? So the first one, Deep Explorer, is designed to detect inconsistencies across multiple models, which helps catch silent or edge cause failures that might not show up like in regular test. Then we have Deep Test, which focuses on simulating conditions like weather or lightning changes, something really useful when we think about flight visibility and different operating environments. And finally, we have last one, Deep Gauge. It measures how thoroughly a model's neurons are being tested, kind of like checking how much of the system's brain is being exercised during evaluation. So these things are done in this. In these are the frameworks which we can use to test those all the models of the machine learning. Then we have this table, and this table is like giving detailed comparison of these frameworks I just mentioned. So it summarizes how each one works, what techniques they use, and how they relate to aviation machine learning. Next, we have cross-domain insight. Actually, in this paper, I didn't just take the papers from aviation or machine learning. I try to add different other domains as well, like healthcare. If you can see, like safety critical system, financial critical system. So this slide actually highlights how other industries handle machine learning system or machine learning safety and what aviation can learn from them. So in healthcare, they use continuous retesting to prevent what's called model drift. That's when AI performance drops over time as data changes. If you can see about transportation sector, there's a strong focus on redundancy and false injection testing. The meaning is like they intentionally introduce small faults to see how systems respond. And in finance, the AI is used to make models more transparent and accountable, which is also really important when dealing with safety critical aviation systems. Next, we have this table, which gives like more details of the same insights I mentioned before. It compares how each domain, healthcare, transportation, and finance approaches model safety, and then shows how those ideas can be applied to aviation. So overall, the takeaway here is that aviation can benefit by combining these strategies. Regular retesting like healthcare, layered fault tolerance like transportation, and transparency like finance to create more trustworthy and safer machine learning system. Next, we have deep learning testing tools. So here I'm showing the main testing tools used for machine learning models in the previous systems or in the previous papers. So Deep Explorer focuses on neuron coverage. It basically checks how well the model's internal parts are being tested. And if we talk about deep tests, it runs scenario-based simulations like changes in weather, lightning to make sure like the changes in weather or lightning just to make sure the model stays reliable in dynamic condition. And if we talk about deep gauge and deep mutation, these both look at robustness. They test how stable a model remains when small faults or changes occur. Finally, TensorFlow is a bit different. It explores rare or unexpected model behaviors, which helps catch hidden errors before deployment. So that is actually a good thing. Before deployment of the software, we can get all the errors beforehand to avoid the cost effect as well. Next, we have table of key frameworks. This table gives a more detailed comparison of these frameworks. It actually outlines their testing approaches, what they focus on, and how they apply to aviation. For example, Deep Explorer. It uses white box testing, why to detect weak spots in flight sensors models, while Deep Test checks how the model performs under real world conditions. And if we talk about deep mutation, it evaluates robustness, as we mentioned before, as I mentioned before in the previous slide, and resilience and TensorFlow, it finds overconfidence issues that could cause instability in aviation system. So overall, these tools provide complementary methods to ensure machine learning systems are reliable and safe before being integrated into aviation workflow. After this table, we have research gap. So through this review, few major gaps stood out. These are the things which I understand after reading all those papers. So first, there is no standardized framework, especially for aviation machine learning testing. Most current methods are borrowed from other industries. They don't have like the standardized one. Second, aviation data is often limited or restricted, which makes it difficult to train and validate all the models. Even the data set I got, it is from NTSB website. They have the actual data set, but it still is like limited or restricted. So you need to find all the information. Still, you are not getting the actual information from there. And lastly, there is still a lack of explainability and real world validation pipelines, which are essential for safety critical environments like aviation. That is, uh, if you can see, like aviation accidents are actually most important in real life because it depends about the lives of the people. Next, we have methodology. This is actually the procedure I followed while I do this research for my survey paper. I started with literature search using major databases to find studies related to AI safety and testing. Then I screened and selected relevant paper based on their focus on aviation or safety critical system, not just aviation, safety critical system as well. After that, I grouped them into three main categories: fault detection, AI safety studies, and cross-domain frameworks. If you remember, I have slides divided into three parts: fault detection, AI safety studies, and cross-domain frameworks, because I took the papers from these three fields. Finally, I extracted and analyzed key data and summarized the finding to highlight current gaps and opportunities. So these are the findings and discussions. From results, it is clear that ML has significantly improved fault detection and prediction accuracy across domains. However, explainability and accountability are still weak points, especially when it comes to trust and automated decision system. Finally, I found that techniques used in other domains like healthcare, transportation could be adapted to strengthen aviation safety systems. So we can use those techniques here to make it more strengthful and to avoid or prevent all the accidents in the future. And now I have slide for the answers. So to wrap up my research part, here's how the main questions were answered. For the first two questions, the study found that machine learning testing methods are mostly metamorphic and adversarial and mutation based. And traditional testing methods don't always work because machine learning models are non deterministic, meaning like they can give different outputs even with similar inputs. When comparing different frameworks, Deep Explore through TensorFlow stood out as the most effective one for fault detection and reliability. And finally, explainable AI and continuous validation were identified as a future direction for making machine learning safer and more trustworthy in the aviation. If we can talk about the conclusion, in conclusion, continuous testing is key to keeping machine learning models reliable over time. And explainability is equally important. It helps build trust and sports the certification process, especially in safety critical fields like aviation. So overall, the aviation industry needs to adopt standardized and automated machine learning validation frameworks. For what? Like to improve safety and prevent system failures before they happen. So all of this research is like related to the accidents to prevent them in the future. Before it happens, we can try to find all the situations and try to stop that accidents beforehand to save the lives as well. So the future directions, looking ahead, there are few important directions this research points towards. First, we need aviation specific machine learning validation standards, something tailored to the complexity of a flight system. And second, expanding and improving aviation datasets, which is going to help make models more accurate and fair. Third, what we need is explainable AI should be built into these systems to make decision making transparent. And finally, collaboration between engineers, AI researchers, and regulators like FAA or ICAO will be crucial for future safety frameworks. These are some of the references that support my research. They include studies on fault detection, AI safety framework, machine learning validation across multiple domains like transportation, healthcare, and aviation, which I discussed before. Each of these papers help build a solid foundation for understanding how machine learning can be applied and tested safely within aviation. So that is all for today's presentation. If you guys have any questions, you can ask me.